Hello students. So in this session we are going to be talking about changing the shape of arrays in NumPy. There are three methods: flatten, ravel, reshape. Let's look at flatten first. It converts a multi-dimensional array into a one-dimensional array. So for example, a 2D array of shape 3 by 4, it will change into a 1D array of shape 12. 3 times 4 equals 12. That's why it gets changed into 12. Flatten, it returns a copy. So if you modify the flatten array, it is not going to change your original array. Why do we even need 1D array? Why do we even need to flatten array? Why can't we work with our original array? Well, that's because many machine learning models, they expect one-dimensional feature vectors, not two-dimensional matrices. Many CNN model, they require your one-dimensional data. So let's say your data is right here in a two-dimension form. If you feed this two-dimension data into a machine learning model, it's not going to work because machine learning model is expecting one-dimensional data. So for that, you convert your 2D into 1D using flatten. In some cases, the data is spatially distributed. In that case, we need to convert into a 1D array. So let's say you're measuring temperature in a building and you have these sensor grids. So let's take a look at this example right here. Each one of these numbers, they represent temperature at a certain place. 2 degree, 1 degree, 5 degree, 1 degree, 2 degree, 1 degree. And you want to calculate the mean or the average or maybe variance or standard deviation of these numbers. For that, you convert this into a 1D array. And now you can invoke NumPy inbuilt method to calculate the mean on average of these numbers. So uh, first we do is import our NumPy as NP. Let's flatten a two-dimensional array to a one-dimensional array. So I create a two-dimensional array right here. It has 3 rows and 3 columns. I print on my original array and I create a flatten array right here. And let me run this. And as you can see, this is my original array right here. And I create my flatten array and then I print my flatten array right here. And you can see it gets printed right there. This is my flatten array. So your 3 by 3 has been converted into this matrix. And you can see 5 3 7 1 5 6 7 8 9 5 3 7 1 5 6 7 8 9. And the shape of this array is going to be 9, comma. The number of elements is going to be 9 because there are 9 elements over here. So the number of elements in both is going to be same. Now let's try to modify the flatten array and compare with the original array. So what flatten does, it returns a copy of your array. So any change that you make to the flatten array, it is not going to affect your original array. So let's look at this example again. This is my array. I print my original array and let's just come back over there. And then I actually flatten my array A and it returns a copy right here. And then on this copy, I change one of the element at index 0, I change it to -66. Then I print my flatten array. And when I print my flatten array, you can see it has changed to -66. Element at index 0 has changed to -66. Then I print my shape, it's 9 right there. Then I print my number of elements, 9. And I'm also printing my original array after that at the end. And look at my original array. This is the original array, and this is my original array, and they have not changed. And that's because my flattened array, when I change this element, it changed the element on a copy, not on the original. That's the thing about your flattening operation. So let's flatten a 3D array to a 1D array. So let's say you have a 3D array of this shape, 2 by 3 by 5. In this case, you have 2 times 3 is 6, 6 times 5 30, 30 elements. So you're going to get a one-dimensional array of 30 elements. So I create an array right here. In this case, I'm creating a 2 by 3 by 5. So you have this one would be right here. This is my first block. This is my second block right here. In my first block, I have 3 rows and 5 columns. My second block has 3 rows and 5 columns. I print my original array. Right there, I print my original array. I flatten it, and then I print the flatten array. So this is my flatten array. I just printed right here. And as you can see, the number of elements over here is going to be equal to 30 because 2 times 3 times 5 equal to 30. Now let's look at ravel. It converts a multi-dimensional array into a one-dimensional array, but what ravel does, it returns a view. So if you modify the raveled array, it can therefore affect your original array. It's not working with a copy. And it's different than flatten because it returns the view. So let's say this is my array, simple array right here. It's 2 rows and 3 columns. I print my array A, and it prints out my array A right there. Then I do a dot ravel, okay, in calling my ravel method. And then I'm printing my raveled array. That prints out my raveled array right there. You can see 1, 2, 3, 4, 5, 6. All right. And then I modify one of the element. And I'm modifying the element at index 0. I'm changing it to 99. And look at that. Then when I print my original array, my A, not the raveled array, I'm printing my original array, which is right here. You can see that element 1, element at index 0, it has changed to 99 right there because of this. This would not have happened in flatten. Let's look at reshape now. It is the opposite of your flatten operation. So what reshape does, it reshapes the array to a new shape of the array as long as the total number of elements remain the same. So can we reshape an array into any shape? The answer is nope. For example, you cannot reshape of 8 by 4 into 4 by 5 because 8 by 4 contains 32 elements. 4 times 4 by 5 will contain 20 elements. So you can reshape an 8 by 4 into 16 by 2 into 4 by 2 by 4 into these different shapes because they are all contain equal number of elements. 8 times 4 is 32, 16 times 2 is 32, 4 times 2 times 4 is 32, 2 times 8 times 2 is 32, all of them are 32. So why do we reshape? Well, some machine learning libraries like scikit-learn, they expect a two-dimensional input. And sometimes you get your input, your raw data in the form of a one dimension. So you have to convert one dimension to two dimension. Sometimes you have to convert a flat one dimensional image to a 2D or a 3D format. That's why you need to reshape. Sometimes you need a 2D structure to do matrix multiplication. If you remember your matrix multiplication, you have rows and columns. So for that, you need two-dimensional structure. Same thing with transpose and broadcasting. So that's why we reshape. So let's reshape a flattened array of shape 18 to 2 by 9. So this is my array A right here. I'm just creating a quick array of 18 elements right there. And I print my flattened array right there. So this is my flattened array over here. Okay, then I'm reshaping it to 2 comma 9. So this is going to reshape by into 2 by 9. Okay, and then I print my array right there. And as you can see, this array has been reshaped into a 2 by 9 array. The number of elements over here was 18, and the number of elements over here is also 18. And as you can see, when I print my shape over here, it's printing 2 comma 9. You can also reshape to, let's say, a shape 18 to maybe this 3 by 6. You can also convert into 3 by 6 because they both have the same number of elements. So I'm doing the same thing, reshape 3 comma 6 over here. Before I did 2 comma 9. Okay, that's going to reshape into 2 by 9. Now I'm doing the 3 by 6. Run this, and that's going to reshape into 3 by 6. 3 rows and 6 columns. Let's reshape into 6 by 3. Same array into shape 6 by 3. You can do that too. Just say 6 comma 3 over here. And that's going to work too. It's going to have 6 rows and 3 columns. If you try to reshape into something else, let's say make it 2, it's not going to work because 6 by 2 is 12 elements. This one has 18 elements. So when you run this, you're going to get an error right there. It has to be same number of numbers or same number of elements. Okay, let's reshape this through 2 by 3 by 3. You can do that too because the number of elements over here is also 18. So when I run this, you can see this is my first block right here. The first block has 3 by 3, 3 rows and 3 columns. And this is my second block. This one has 3 by 3 matrix inside. Okay, now let's reshape a flattened array to 3 by 2 by 3. You can do that too. You can say 3 comma 2 comma 3 right there. Okay, and it will reshape that happily for you. Now another way to flatten is to use reshape with argument -1. That's another interesting way. So -1 basically is telling NumPy that, hey, figure it out what the shape is. It's a special instruction. So let's say this is my 2D array, I print my array right here. All right, print my array. And let me run this, print my array. Then I'm saying array dot reshape, and I'm specifying -1. So I'm just saying that figure out what the shape is going to be by looking at this. And you see that it figured out on its own. It's going to be right here. It's actually reshaped into one-dimensional array. Uh, let's convert a 2D shape into -1 comma 3. Okay, -1 by 3. So in this case, -1, what's going to happen? Python will figure out, or NumPy will figure out what this shape should be based on the input array. So this is my input array right here. All right, and I'm saying array dot reshape -1 comma 3. Now, how many elements this one has? Well, this has 5 rows and 3 columns. So 5 times 3 is 15. There are 15 elements over here, and I want this to be 3. So this should be 5. And NumPy will figure out this is 5. And you can see that it actually created 5 rows over here. Okay, you can do the same thing with, I can do 5 by -1. Okay, so I can just say 5 comma -1 over here, and your NumPy will figure out what this number is based on this right here. When I run this, it's going to work just fine. What if I try to change this to maybe, okay, this one actually has 15 elements, right? Now 15 is not a multiple of 7. So if I put 7, it's going to throw an error because 7 is not a multiple of 15. You cannot reshape 15 into any matrix that will be 7 by something. That's not possible. Okay. All right. So summary, what is the difference between flatten and ravel? Well, flatten, it returns a copy of your array. So changes do not affect your original. Ravel, it returns a view of the array when possible. So anytime when you make a change to it, this may affect the original. Reshape, it changes the shape of the array without changing your data. So use flatten when you want a separate independent array. Use ravel when you just need a quick 1D view of the same data. And use reshape when you just want to change dimensions, like 2 dimension to 1 dimension or 1 dimension to 2 dimension. Thank you.